I had a couple of you ask about, this is question number 17 on the My Math Lab that corresponds to question number 67 in the textbook. And I had a couple of you ask me questions about this, so I thought we'd work through it. So we're asked to find all points in the first part where the graph of f has horizontal tangent lines. And we're asked to give the answers as ordered pairs. Okay. So let's see if we can figure out where that is. So the first thing I would say is just kind of give yourself an abstract problem here. This is not going to be the graph of our function. Let's suppose this was the graph of f of x. What are we trying to do here? Well, we're trying to find the points where we have horizontal tangent lines. So to do so, we're going to find the derivative of this. Maybe the derivative, I'm not sure, maybe the derivative of this function looks something like this. And I'm not completely sure, but maybe it looks, let's say, something like this. So notice that the places where f has horizontal tangent lines then will be precisely the places where the derivative is 0. So rather than working with the graph of f and saying, well, where does this have horizontal tangent lines, we're going to find the derivative of f and then set it equal to 0 to find its x-intercepts. So that's our strategy. Let's get started. So we're given f of x is equal to, in this problem, 18 radical x minus 3x. So f prime of x would be equal to, I've memorized the derivative of the square root function. It is 18 over 2 square root of x minus 3. If you've forgotten the derivative of the square root function, remember if I had given you something like, I don't know, h of x is equal to the square root of x. If you first rewrite it as x to the 1/2 power, then you could go ahead and use the power rule on it. Which we could then rewrite as 1 over 2 radical x. However, I recommend simply memorizing this rule. When you're given the square root of x, we know that that's its derivative because we use this particular derivative so often. So now that we've got the derivative as a function, and again, my graphs are made up. They're not corresponding to this problem, but they kind of give us an insight for what we want. We're now going to look for where the derivative, f prime of x, crosses the x-axis. So how do we do that? Well, we write set f prime of x is equal to 0. And I highly, highly recommend that you actually write this step out to yourself. Sometimes people get confused in these problems, and if you give yourself some directions, like saying, I am setting this equal to 0, rather than just doing so, I think it helps you focus a little bit more. Okay. So we're setting f prime of x equal to 0. So this is equal to, we have this expression here. First of all, I can simplify this radical, so this would be 9 over radical x. And then if I add the 3 over to the other side, I'd have something like this. So now let's go ahead and multiply both sides of this equation by the square root of x. Okay, we can do that as long as x isn't 0. Okay. And if we do so, we get 9 is equal to 3 radical x. Okay, now let's go ahead and square both sides of this equation. By the way, I could have divided that 3 over first. That would have been a better move, I think. Anyway, we get 81 is equal to 9x, because when we square x squared, we just get x. Finally, solving for x, we get 9. Now, because we at one point squared both sides of the equation, we should check to make sure that there are no extraneous solutions here. So I should actually double check that 9 works in this problem. So if we go back to the original derivative, 18 over 2 radical 9, plugging in 9 for x, let's see what we get. Well, we get 9 over radical 9 minus 3, which is 9 over 3 minus 3, which is 3 minus 3, which equals 0, which is what we intended it to be. So then this is indeed a 0 of the derivative. So again, at this point, what we've said is, hey, I found a place where this function crosses or touches or crosses the x-axis for its derivative. For its derivative, though. So that's not going to be, we don't want to know the ordered pair where the derivative is 0, but instead we want to find out, okay, what's our actual point on the function? So now that I've found where the derivative is 0, let's actually find the corresponding ordered pair on the graph. So what can we do? Well, we return to the original function. F of x is equal to, I'm afraid I've lost it, I'm sorry, 18 radical x minus 3x. So then if we plug 9 into that, we get f of 9 is equal to 18 radical 9 minus 3 times 9, which is equal to 18 times 3 minus 27, which is 54 minus 27, which is 27. So the point on this curve where we have a horizontal tangent line is the ordered pair 9, 27. Okay. So let's actually look at what the graph of this function would look like. Notice that it passes through the ordered pair 0, 0, and what it would do is initially, so it's only defined for positive values of x and 0, so anyway, initially it would rise, and then we would see it take off, something like this potentially. And so what are we doing? Well, we're asking, where does this thing have a horizontal tangent line? On the graph we can see it's right there, and what is that coordinate? It is the coordinate 9, 27. Okay. The other thing we could see is if I actually graphed, so that would be the graph of f of x, it would look something like this. I didn't do this perfectly, so it might be slightly off from that. But if we looked at the graph of f prime of x, the graph of f prime of x would look like this. Something to that effect. And notice that f, so this is f prime of x, and notice that precisely where f of x has a horizontal tangent line, that is where f prime of x has a 0. So again, what we did, and let me make sure we can read that as f prime of x. So what did we do? We took our function f, the blue function. We couldn't figure out where that point was on our own, so we then found the derivative, the f prime of x, and we set that equal to 0 to find out where it touched across the x-axis. We found that it touched across the x-axis at x equals 9. Then we went ahead and plugged x equals 9 into the function, and that's how we found this ordered pair here. I hope that helps. If you have any questions, let me know.